September 7, 1940. 02:14 a.m. Somewhere along the windswept coast of Kent, England, a cold mist clings to the radar station's metal lattice. You can almost taste the salt in the air, tangling with the faint, acrid burn of machinery. Inside, the hum of generators fills the room like a low heartbeat. Men huddle over dials and oscilloscopes, eyes wide, fingers twitching over knobs and switches. A blip flickers on the cathode ray screen. One, two, then dozens. Luftwaffe bombers hundreds of feet off the ground, slicing through the darkness toward London. Outside, not a single gun flashes, not a single plane rises. The RAF fighters are still in their hangars, engines silent, pilots shivering in leather jackets. Yet in this room, a hidden war is unfolding. Air Chief Marshal Hugh Dowding leans over a map table, his jaw tight, eyes scanning the dots as if he could see the planes in 3 dimensions. He doesn't panic. He doesn't yell. He trusts something invisible, something that defies sight, smell, and sound, something that turns night into a weapon. You see, most commanders rely on instinct, on experience, on what they can see with their own eyes. But Dowding has something the Luftwaffe cannot touch, something they will never anticipate. A network of radar stations, each a sentinel along the coast, feeding live intelligence to the fighter command's nerve center. And at the heart of it, there's a man, a quiet, brilliant engineer who has spent years tinkering with circuits, wires, and early warning theory. Some call him eccentric, others call him obsessive. But tonight in the darkness, he is the man who will decide whether London lives or dies. His calculations will guide Spitfires toward the enemy, not by luck, but by cold, precise mathematics. The screens flicker again. A new formation approaches from the east. The operators check their readings. The frequency shifts. A correction. The map updates. And somewhere high above, you can imagine RAF pilots straining their eyes into the black, unaware that they are already being directed, led by an unseen hand. And yet, even here, even now, danger lurks. One miscalculation, one blown circuit, and all of London could be illuminated in flames. The stakes are silent but colossal, and the enemy, they are blind to it. But there is something more, something the pilots, the commanders, even the enemy do not know. The machine in this room is about to reveal a secret the Luftwaffe could never imagine. By dawn, September 7, 1940, the mist begins to lift along the Kent coastline, revealing a patchwork of radar towers stretching like sentinels into the gray horizon. Inside the operations room, the engineer wipes sweat from his brow. Every dial, every gauge, every cathode ray flicker matters. He doesn't just see numbers, he sees lives, hundreds of them, thousands. The blips on the screens are forming a pattern now, a swarm of Messerschmitt Bf 109s and Heinkel He 111s, moving in tight formation, heading for the industrial heart of England. At Fighter Command Headquarters in Bentley Priory, the tension is electric. Air Chief Marshal Hugh Dowding studies the map, tracing the enemy's projected path with a white-gloved finger. He doesn't shout. There's no panic. Only a quiet, calculating focus, the kind that comes from trusting something you cannot see but know will not fail. Through a series of switches and wires, the engineer channels this invisible intelligence directly to the pilots. Spitfires roar to life in their hangars, engines shuddering like caged beasts. You can almost feel the vibration through the soles of your feet. Each fighter takes off at precise intervals, vectored by signals, guided toward the incoming Luftwaffe force like moths drawn to a flame they cannot see. From above, it would appear chaotic. RAF fighters scrambling in the gray light, enemy planes descending in formation. But below, in the quiet rooms of radar stations, it is choreography, calculated, perfected over years of testing, failures, and sleepless nights. What seems like luck in the skis is mathematics made manifest, a silent war being waged far from the smoke and fire of the bombs falling over London. And yet, for all the precision, the threat is immediate. One misread signal, one mechanical failure, and the entire strategy collapses. The Luftwaffe has the element of surprise, speed, and numbers, but they cannot touch this invisible shield. And as the first bombers appear over the Thames, guided by nothing but blind courage, the RAF is already moving, intercepting them with the kind of timing that seems impossible. Somewhere in the heart of this invisible battle, the engineer glances at the readings, his hand hovering over a switch. A hesitation, then a decisive flick. The next wave of pilots is now en route, vectored with a precision that no human intuition alone could achieve. And somewhere above, the enemy is heading straight into it, unaware that their every move is being tracked, predicted, countered. But even the best systems are not infallible. And as the first explosions echo faintly in the distance, there's a chilling realization waiting to strike. The Luftwaffe will adapt. They will try to outsmart the invisible. They will test every wire, every circuit, every signal. And the next night may not go as smoothly. Night falls again over southern England. The sky is a deep, velvet black, broken only by the faint glow of searchlights sweeping the clouds. Inside a small, dimly lit radar station, the engineer sits hunched over a tangle of wires and switches. Sweat streaks his face, eyes reflecting the tiny green blips on the cathode ray screen. Around him, the room hums with electricity and anticipation, a living organism powered by calculation, timing, and nerve. This man, Robert Watt, is the silent hero of Britain's defense. He is not on the battlefield. He will not fire a gun. Yet tonight, his inventions will decide whether the Luftwaffe strikes terror into London or is met with precise, deadly resistance. Every pulse of radio waves he sends out searches the night, bouncing off enemy aircraft and returning with vital data, invisible yet undeniable. You can almost feel the tension. Outside, the wind wails across the cliffs. In the distance, aircraft engines murmur. Inside, Watt adjusts a calibration knob, then a switch. A blip appears on the screen, then another. The data flows to the Fighter Command Operations Room at Bentley Priory, where Dowding and his staff turn this invisible information into life-saving decisions. It is as close as war gets to magic, machines predicting death and dodging disaster with cold precision. The Luftwaffe pilots have no idea they are being watched. They trust the night, the cover of clouds, the speed of their formations. But each man in the air is being tracked, measured, and anticipated. The RAF pilots, vectored by radio signals, strike with the accuracy of a predator, guided by the hand of a genius they will never meet. The sky becomes a chessboard, with pieces moving according to unseen calculations. But Watt knows the stakes are not abstract. He remembers every failed test, every night spent alone in a freezing shack, the endless hours tuning circuits until they sang. And now, in these critical hours of the Battle of Britain, every decision, every signal could mean life or death for hundreds of pilots, thousands of civilians. He feels the weight of it pressing down like the black clouds outside. Then a signal spike. A sudden cluster of blips moves faster than expected. The Luftwaffe is adjusting, testing, trying to shake the invisible eyes that track them. The engineer stiffens. He knows this is the moment when theory meets reality. One wrong adjustment, one misreading, and the RAF fighters could be sent flying into disaster, or worse, London could burn. And as the first British planes climb into the black, guided by pulses of electricity and human ingenuity, a thought flashes through the room. The night is no longer neutral. It has a master. And soon the enemy will realize that something is hunting them, something they cannot see. 3:27 a.m., September 7, 1940. Over the darkened skies of Kent, you can hear the distant drone of engines. The Luftwaffe formation stretches for miles, Heinkel bombers followed by fighter escorts, their silhouettes ghostly against the faint moonlight. From below, radar stations hum like living hearts, sending pulse after pulse into the night, invisible beams slicing through the darkness to catch every movement. High above, RAF Spitfires begin to climb, vectored by signals sent through the delicate web of wires and radio transmitters crafted by Watt and his team. You can almost feel the pilots, adrenaline, hearts pounding as they bank into clouds, searching for an enemy they cannot yet see. And yet, they are not flying blind. Each aircraft has been guided with precise timing, arriving just seconds before the bombers reach their targets. In Bentley Priory, Air Chief Marshal Hugh Dowding watches the radar plots on the screens, tracing the incoming formation with calm determination. He knows the enemy's speed, altitude, and approach vector before the first bomb hits. Unlike previous wars where commanders relied on reports that arrived too late, Dowding wields the power of prediction. And prediction, in war, is everything. The first Spitfires break through the clouds. Cannons flare, tracer rounds streaking across the sky. The Luftwaffe is caught off guard. Pilots glance for the source, but the attacks come from everywhere at once, guided by calculations, not chance. Bombers are forced off course. Fighters are cut down before they can respond. The chaos above is breathtaking, and it all began with a man and his machines miles below, feeding data, adjusting frequencies, calculating trajectories in real time. But the Luftwaffe is not easily defeated. They regroup, adapt, push harder, and the radar stations must respond faster than ever. A single miscalculation, a delayed transmission, and entire squadrons could be lost. Watt's hands fly over dials, correcting, recalibrating. The technology is remarkable, but it's the human mind behind it that keeps the system alive under stress. And then a new anomaly appears on the screen. Blips moving in ways the engineers didn't predict. The enemy is experimenting, trying to jam, to confuse, to destroy the invisible eye. And suddenly you realize, this war is no longer only fought in the air. It is being waged in waves of electricity, in circuits and wires, where one man's brilliance could turn the tide or see everything collapse. The radar operators hold their breath. September 7th has already stretched into hours of tension, and now, just as dawn begins to bleed light into the sky, the Luftwaffe changes formation. Faster, tighter, more erratic. The early warning system that guided the Spitfires so perfectly is being tested in real time. The green blips jump across the cathode ray screens, teasing, taunting, daring a mistake. Inside the small hut on the cliffs, Watt leans closer to the oscilloscopes. Fingers trace patterns, calculations firing faster than any human could speak. He adjusts a frequency here, recalibrates a pulse there. The radar network isn't just a machine, it's a living extension of his mind, bending and adapting to every unpredictable move the enemy makes. Every pulse of electricity is a silent command to the fighters, every adjustment a lifeline for the cities below. Down at Bentley Priory, Dowding watches as the RAF pilots respond almost instinctively. He doesn't shout orders, he simply trusts the invisible network guiding each plane. Spitfires swoop into positions that seem miraculous, intercepting the bombers with uncanny timing. You can almost hear the roar of engines split by gunfire. The flash of cannon bursts in the dawn sky, the crackle of radio signals threading through the chaos. But the Luftwaffe isn't finished. Messerschmitts dive and roll, trying to evade interception, and bomber groups press onward, determined to strike. Each maneuver is countered by invisible hands, waves of mathematics, engineering, and instinct, keeping the balance teetering. You begin to realize that this isn't just a battle of planes. It's a battle of perception, intelligence, and technology, and one mistake here could change everything. Back at the radar station, Watt notices something. A subtle pattern in the enemy's evasive movements, a rhythm in the chaos. He signals the operators to adjust the plotting, rerouting RAF squadrons in near real time. The night that once belonged to the Luftwaffe is slowly turning into a deadly trap. London's skies are not merely defended, they are orchestrated. And yet, even as the first wave of bombers falters under precise interception, a shadow of doubt creeps in. The enemy is learning. The next raid will be different, faster, smarter, more deadly. And the question hangs in the air. Can the invisible shield continue to protect the nation when the enemy begins to anticipate it? By mid-morning, September 7, 1940, the skies over southern England are a battlefield of light and shadow. Smoke curls from scattered bombers forced off course. Tracer fire arcs like lightning between clouds. Spitfires dive and climb, weaving in patterns that seem impossible. But every move has been calculated, predicted, and guided by radar pulses hundreds of miles below. Inside Bentley Priory, Air Chief Marshal Hugh Dowding leans over the plotting table, his eyes sharp despite exhaustion. He traces the last movements of the enemy formation, nodding the retreat, and allows himself a brief, almost imperceptible nod. The invisible system, the one that many had doubted had worked. The Luftwaffe had been anticipated, intercepted, and denied the advantage of surprise. Back at the radar stations, Watt and his team exchange tired smiles. Their instruments hum steadily, almost smugly, as if aware of the miracle they've wrought. What seemed impossible, the guidance of fighters to exact intercept points in the dead of night, had become reality. And yet, there is no celebration. The war is far from over. Every successful interception is a fleeting victory in a longer, bloodier struggle. You can almost feel the city of London below, still holding its breath, unaware that the quiet hum of machinery and the sharp minds of engineers above had kept the destruction at bay. Civilians emerge from shelters, stepping into a city saved not by brute force, but by ingenuity, calculation, and invisible waves of electricity slicing through the night sky. And then comes the thought that will haunt both men and commanders alike. The Luftwaffe will adapt. They will attempt to jam, confuse, and destroy the network. Each new attack will test the limits of human endurance, engineering, and strategy. Tonight, radar proved itself. Tomorrow, the skis may demand even more. But for now, there is awe. For the first time, the Battle of Britain has a weapon the enemy cannot see, cannot counter, and cannot anticipate. An invisible shield built from wires, circuits, and human brilliance, turning night into a battlefield the RAF controls, even when the darkness itself seems to favor the enemy. And somewhere in the quiet of his station, Watt realizes something chilling and exhilarating. This is only the beginning. The war has entered a new era, one in which mathematics, electricity, and ingenuity are as lethal as bullets and bombs. And the next encounter, when it comes, will test everything he has built and everything the RAF has learned. Even as dawn breaks fully over Kent, the tension lingers. September 7, 1940, will be remembered as one of the first nights the RAF truly dominated the skis, but the victory is quiet, almost invisible. The air smells of damp earth and faint smoke from distant skirmishes. The radar stations hum on, relentless and uncelebrated, their green blips silently scanning for the next threat. Watt leans back in his chair for a moment, exhaustion weighing on his shoulders. He has seen the impossible realized tonight, machines and minds working in harmony to turn an intangible idea into a weapon. Yet he knows the enemy will learn, adapt, and perhaps strike where the system is weakest. The stakes have never been higher. Every radar pulse is a lifeline, every decision a gamble. Dowding, too, feels the weight of what has been achieved. From the quiet command room of Bentley Priory, he watches pilots return, planes streaking low across the countryside, engines roaring with triumph and fatigue. They do not see the invisible hand guiding them, the calculations that orchestrated their success. Yet without it, many would never return. And Dowding knows, the RAF now possesses an edge the Luftwaffe cannot fathom. But there is a lesson woven into every pulse of the radar screens. Technology alone does not win wars. It is the human element, creativity, courage, persistence, that turns circuits into strategy, calculations into life-saving interventions. Watt's genius is meaningless without the bravery of pilots who trust signals in the night. And the enemy, relentless and adaptive, will continue to test that fragile link between man and machine. As the day unfolds and the sun climbs higher, a creeping anxiety settles over the radar stations. New formations will come. The Luftwaffe will probe weaknesses, search for blind spots, attempt to turn the invisible shield into a liability. And in the minds of those manning the instruments, the same question repeats like a pulse through the circuits. Can ingenuity outpace determination? Intelligence outmaneuver experience, and technology endure the relentless trial of war. Yet in the shadows of that Kent morning there is also awe. You begin to realize that the Battle of Britain was no longer just fought in dogfights or on the streets of London. It was being fought in waves of invisible energy, guided by human brilliance, daring, and vision. And the man who made night a weapon, Robert Watson Watt, has changed the rules forever. The skis are quiet for now, but far off the coast, engines hum faintly, carrying the next wave of the enemy. And when they arrive, the invisible war will continue, testing every skill, every innovation, every heartbeat of those defending Britain. Weeks pass, but the tension never lifts completely. Radar stations along the southern coast remain vigilant, their towers like silent guardians watching for any sign of the Luftwaffe. Pilots speak in hushed tones of their miraculous interceptions, never fully understanding that each maneuver, each deadly dive, was guided by unseen hands, by pulses of electricity traveling faster than any human eye could follow. Watson Watt walks among his engineers, checking calibrations, adjusting circuits, refining the system. He notices small improvements, better signal processing, faster plotting, more accurate predictions. Each enhancement is a small victory, invisible but profound. It is a war waged not with fire and blood but with intellect and precision, where human ingenuity amplifies every watt of power and every flicker on the screen. Air Chief Marshal Dowding watches from Bentley Priory, the maps before him now dotted with countless victories, each representing pilots saved, bombs thwarted, lives spared. He knows the radar network has shifted the balance in Britain's favor, yet he is also aware that it has opened a new front, one of technological warfare. The Luftwaffe may still dominate in brute force, but Britain now controls the unseen. They have weaponized the night. And the implications stretch far beyond a single battle. The success of radar in the Battle of Britain will ripple into every theater of war. Fleets will be guided across oceans, armies warned of unseen approaches, bombers intercepted before they strike. Watson Watt's invention has not just saved London, it has rewritten the rules of engagement, proving that sometimes the deadliest weapon is invisible. As you imagine the nights that follow, consider this: pilots racing through darkness, engines screaming, guided by pulses of radio waves, facing an enemy unaware of the silent eyes tracking them from below. Every victory above is owed to ingenuity, to circuits and switches, to the mind that refused to accept the night as a handicap. And though the battle rages, one truth is undeniable: the era of invisible warfare has begun, and Britain now leads the charge. Watson Watt leans against a tower railing, staring out at the fading horizon. Somewhere far above, Spitfires cut through the clouds, their pilots unaware of the hands that guide them, the calculations that save them. And yet, for those who understand, a quiet pride pulses through every signal sent. They have turned night into a weapon. They have done the impossible. The next raid will come. The Luftwaffe will try again. But the invisible shield is ready, adapting, evolving, relentless. And in that quiet hum of machinery, in every flicker of the radar screen, you realize something cinematic, almost mythic. In this war, intellect can strike harder than steel, and night itself has a master.